Ouais, je pense que live start directement. Ok, je pense que c'est bon. Je pense on va attendre 3 minutes باش يجيو suffisamment de personnes. On va commencer, Inch'Allah. Salam alaikum. Bonjour à tous. اليوم on va faire une nouvelle conférence, une série de conférences pour l'intelligence artificielle ديال ماتي ماروك. واليوم معنا سوسن قدامي اللي هي research scientist في Amazon qui est في mon opinion une inspiration للمغاربة كاملين تبارك الله عليها, qui a un parcours très inspirant. Où Sousan, elle va nous faire une petite présentation. Elle a Generative AI en pratique, le Python. Generative AI, c'est quelque chose qui a explosé récemment, mais les récentes applications, les que je vois Internet, comme DALI ou AI Art. Donc, je pense que la présentation de Sousan, elle va être très intéressante et très enrichissante. لا من ناحيه لا كولتور جينيرال, لا من ناحيه هذوك اللي بغاو يتعلموا شي سكيل جديد اللي يكون اوتيل في هاد ليبوك هادي. بون دونك غنخلي سوسن تهضر, ما نطولش بزاف. جو مي لي سلايد سوسن ياك.
D'accord, je veux déjà te remercier Omar pour la présentation et également pour l'initiative d'El Maroc qui font vraiment plaisir à partager l'information aux Marocains et à élargir le cercle de partage. Donc, je souhaite vous remercier en général pour les étudiants pour le cadre des Generative AI. Avec partager avec vous des informations pratiques articles sur Generative AI qui sont d'actualité en ce moment. Et sur Teams Phone,
je pense qu'il y a toujours un problème de micro.
de micro.
En fait, واش عندك شي ميكرو واش ديال البيسي ولا
Le micro d'Yali, pas d'Yali PC. En fait, est-ce qu'on peut essayer est-ce que tu peux désactiver
Je peux faire ça, mais je pense pas que ça change.
Ok, parfait. Donc là, est-ce que tu m'entends bien? Est-ce que tu m'entends mieux? Ou là, il y a toujours un problème?
Ça va. Je pense juste, il faut éviter qu'il y ait du bruit de fond qui يتخلط مع الصوت ديالك وصافي.
Ok, parfait. Donc, je vais aussi essayer un peu plus fort. J'espère que ça va aider pour la qualité de la voix. Et Omar, merci de me signaler s'il y a des problèmes. Je ferai attention.
Ça marche, je suis là. Donc, je te mets les slides. C'est bon?
Oui, ok.
Donc, Anna, je te laisse. Voilà. Anna, je serai dans les coulisses.
Parfait, merci beaucoup Omar. Donc la présentation, on va la faire en anglais parce que c'est un sujet où on trouve beaucoup de documentation en anglais, donc c'est la langue un peu cible. Mais on peut discuter par la suite de la langue que vous souhaitez, donc on peut avoir des questions, des discussions en arabe, en français, en anglais aussi si vous souhaitez. Je souhaite avant de commencer aussi dire que je parle à mon nom propre pour cette présentation. Je ne représente pas AWS, mais ça me fait plaisir de vous partager les actualités autour du sujet, que ce soit en lien direct avec AWS et ses produits, ou aussi en lien avec les développements qu'on peut faire sur Python en général, pour quelqu'un qui ne va pas forcément utiliser les services AWS. Voilà, donc je pense qu'on peut commencer. We can start. So the point of this conference is to talk about how we can build generative AI models in Python and through AWS services. And I think that I will present the agenda of what we will be talking about today. So we will first have an introduction to generative AI in general. We will talk about generative AI applications and benefits in industrial environments and in business applications in general. Then we will talk about the theoretical frameworks for building generative AI models, and this would be particularly interesting to engineers and also to people with technical background in order to understand what the different possibilities are around this building. It can also be interesting to know for people who are just interested in the topic, and we will then convey some practical tools for building generative AI models. And actually, these tools can require some technical background for some, and for some, they don't even require a technical background. And this is what we will be presenting, which means tools that anyone can develop using some skills that are not necessarily coding skills. And then we will end up with some tips and tricks from the last literature on how to customize our generative AI models, which are tricks that are well known to the scientific community and which can help developers build more robust and more customized generative models for their business cases. So first, let's talk about an introduction to generative AI. So we all have heard of ChatGPT in recent times. And generative AI has the fastest growing trend in AI ever. And we can see this from two perspectives, either from the developer adoption perspectives or for the consumer adoption perspective as well. So for developer adoption perspective, we can see that Stable Diffusion, which is a generative AI models for computer vision, for images and videos, has reached 40,000 developer users and stars on GitHub in only very small days after the launch. We see that here we have in the x-axis the days of launch, and there we see the adoption. We see that the Stable Diffusion one was a very rapid adoption for developers as compared, for example, to the Ethereum or Bitcoin, which are among the fastest adoptions as well. But we see that here the developers have easily started using, started talking about these models because they are easy to use, and we are going to understand how we can use these. The same applies actually from general consumer adoption when we talk about ChatGPT that reached rapidly above 1 million users just in 5 days. If we compare this to Instagram, for example, it is 75 days to get the 1 million adoption. And to Spotify, it required 150 days to get this 1 million adoption. Well, ChatGPT got this in around 5 days. And this shows us that this is an interesting topic. This is something people are interested in. And this is a fast growing trend. Either we view it from a technical perspective or also from a general consumer perspective. So what is generative AI? So generative AI are machine learning models, AI models, that are able to generate content. And this content can be close enough to what humans have generated. I think you can relate to this if you have ever interacted with ChatGPT and seen how ChatGPT is reacting, how he is generating new content, responding to your questions or to your requests. They are powered by the so-called foundation models. So foundation models are very large pre-trained models that are trained on very large data sets, like models trained on internet, on Wikipedia, on huge data sets, in order to train 100 billion parameters and to come to a very efficient accuracy for these models. And these are models that are available to the public, some of which are open source, some of which are not, but these can be used to build the so-called generative AI. The generative AI is also interesting from a business perspective because it can be applicable to many use cases, ranging from summarization, question answering, digital art creation, code generation, and so on. So we can really apply it to a big range of possible use cases, and we can even recast some natural language processing models that required from us as developers a huge amount of work into generative AI ones. It can also be customized for specific domains. And actually, if we target to realize a certain specific task, for example, we are interested to apply ChatGPT into a press environment, then it may be interesting to actually customize our model to this applicable use case to gain in accuracy. And we are going to see in details all of that. And here you have on the right of my slide some examples of generative AI-based pictures that were generated in order to give a design of a car. And you see that this could be also interesting. Here we are relating to the art creation and to image creation. Let's talk a bit in more practical terms, probably scientific terms. So we have artificial intelligence, which is this discipline that helps to create artificial intelligence, which means to mimic the human intelligence through computers, to some mathematical frameworks that can actually mimic some things that we used to do as humans, and that is part of the human intelligence. And as part of this, we have the machine learning models. That is a specific case of the artificial intelligence based on learning from the past to predict something in the future, or learning from not necessarily the past, but a set of data in order to make inferences or to create structure and meaning in the data. And within that, we have deep learning. And deep learning are basically black box models that are using some mathematical frameworks like convolutions or recurrence frameworks in order to create even more accurate models when we talk about machine learning. And inside of this deep learning, we have the transformer models that are the basis of what generative AI is about, which can be either using the transformer architecture or only using the first encoder architecture, like what BERT does, or using the second part, which is the decoder part in a transformer, like what ChatGPT does. So the update is that we have a very fast evolution of these models that are really related to more capabilities in calculations. So the more complex the model is, as we see here, so here we have ChatGPT, which is around 10 to 25 number of parameters as compared to previous models. And you see that we have more and more adoption that is related to the increase in accuracy. And accuracy is powered by the increase of resources we can do, the amount of data we are able to process today, the amount of capabilities we have in order to process these data and all of that, which has pushed the generative AI models to the next level. This actually happened, which we can call the accuracy revolution, happened first with the deep learning models. And here we see in the graph on the left how the test loss has decreased when we are increasing the compute capabilities. So the possibility of being able to scale and neural networks and general deep learning models help to reduce drastically the test loss. So the more resources we have, the more data we have, the more software capabilities we have to tackle this data, the more accurate we get in terms of test loss. We can also push these models into an even better accuracy through some customization. Here we see how applying the PPO, which is an instruction-based customization based on human feedback, helped increase by a factor of 2 or 3 the accuracy of a bare GPT model, which is the next step, which means that we have now capabilities and pre-trained model with much more accuracy. And along with that, we can push these models into the next level of accuracy through proper customization. Here I want to give you an example on the impact of this revolution. So we see here on the left a picture. This picture was generated by a robot when we asked the robot to generate a picture of a very clean living room. And this was done with the state-of-the-art model in 2016, which was called the Stack GAN. And you see here that the picture generated is not really very clean living room, right? So we have some problems. We have the window going to the wall. We have some problems in the picture. It's not really clean or not tidy. And on the right, we have the new picture generated with the exact same prompt, a picture of a very clean living room, but using Stable Diffusion, which is a model of 2022. And we see a big difference in what we are able to generate, right? We see a big this is more of a very clean living room, actually. And we can see this impact, this direct impact of the accuracy revolution on practical generations. Now let's talk about where generative AI could be applied and what the benefits are of generative AI as compared to traditional models, probably. So generative AI has the specificity to be able to be applied to a range of different application cases. Generative AI can help increase the productivity through text generation. It can also help us create some chats, for example, for chatbots or for virtual assistants. It can help summarize text, for example, when we give a text and then we can get a summary out of it, and we can even customize the way our summary is generated with more sophisticated tool. It can help for search, for code generation, and here we are talking about tools like Code Whisper, who helps the developers have suggestions for code, correct their code, or give some comments to their code on live. It can help for image generation, and we've got an example before on how Stable Diffusion helps generate images out of a prompt that we give these models. It can also help for other things like image classification, to create music, to generate videos, to generate code. So it has a wide range of possible application cases. And what is very interesting about that is that it is not only applied to different use cases, it is also applied in an easy way to these different use cases, because we are benefiting from the accuracy of foundation models that already come with a huge pre-training experience, which can help us have good accuracies in a short amount of time. For data scientists and developers and scientists, many machine learning tasks, traditional machine learning tasks, can now be just recast as generative. And we will see a concrete example as well on that. So this is an example. For example, when we have a task that is saying, I'm not into this house, it's too expensive and too far from the train line, and we want the model to classify this into a negative sentiment, this is referred to as sentiment analysis in traditional machine learning. And this is a traditional classification problem. Yet, we can apply the same with generative AI through just a recasting, which means using the generative AI models to adapt it to make a classification without really building a classification algorithm. For example, we can tell the generative AI models, I'm not into this house, it's too expensive, too far to the train line, and we ask the model to classify this sentence into either positive or negative sentiments. And the generative AI models would tell us this is a negative sentiment. So basically what we have done here is that we are making a classification, a traditional task, through generative AI, through just recasting this previous task into the new task. What is the gain in this recasting? In order to construct this sentiment analysis or traditional classification for sentiments, we need to build a model that would take us a lot of time. we need the classification model and to fine-tune the model and choose the best one. We also need to have a labeled data set and train it. We need to train it and test it, and we need to take a lot of time as developers and scientists to have an outcome and a robust model. With generative AI models, we are going to directly get an output and directly get a model that can do that for us, just through a prompt, just through asking the model, just to add in, classify the sentence into positive and negative sentiment to our original input. And this would give us directly the classification, which means that a task that would take an average scientist probably 1 to 2 months time would now take him only 5 minutes. I agree that there is a limit to that, which means that there are questions around the robustness of this generation, but there are also ways to tackle that in order to achieve more steady results. And the point is, even with traditional ML models, we always have a risk that we are going to minimize. We can also do the same for generative AI models through some ensembling or some post-processing to ensure robustness, but we will get a result in a very rapid way, which can help deliver results rapidly. The consequence of that is creativity. The first thing is we can now create new content out of robots and new ideas, including conversation stories. We can have generate poems, we can generate images just through a robot. And this can help us increase our creativity, view the thing from a different point of view. And this is applicable, for example, to cases like art, where we are going to generate a new car design, and we are going to think of the way we are generating designs, which can really help on the creativity side. The second point is productivity. I give you an example before on how these traditional machine learning models that required a lot of time, a lot of work, a lot of things in order to have something that works are now just recasted through a generative AI task. So it's going to help increase the productivity. A model that would have taken us in the past probably 2 months to develop to get a bare first output can now be done into 5 minutes work. And so it increases productivity. We can also view that from the code whisper perspective that can help people have access to some recommendations in the code and some recommendations to generate code, to correct code, to comment code, and so on. And so it helps actually the developers through test that was conducted be 55% faster, 57% faster in task completion. And generative AI models, through these benefits, are expected to make a huge growth in economy, which is around $7 tera increase in the global GDP over the next 10 years. So we have positive expectations of growth, which is absolutely interesting from strategic perspective. Let me give you a concrete example to get out of these generalities. So let's say that I asked you, my audience, to learn everything on the internet. How would you do that? Of course, you would need structure. You would need data that is structured in a certain way to learn on. You would need storage, actually, where to put this data, where to summarize it, and time. Given that we have around 5.74 billion pages on the internet, and that it would take you around 52 seconds to learn every one of these pages, this equals to 82 million hours of work. And this equals as well to 40,000 human years. So you would spend 40,000 human years to learn everything that is on the internet. A foundation model can do this in few minutes. And here we see the real gap, the real capabilities that we can empower through these very powerful models that can actually help process huge amounts of data. And this is practically applicable, of course, to our business environments, where we are interested to take good use of our data and to process it the right way in order to extract value. Now let's talk about the building of generative AI models. I think most of you could be probably interested in how to move forward with that, how to really be able to develop my own generative AI model, how to be able to manipulate a generative AI model, how to create a model out of generative AI that can help a specific business requirements from my end. And here we are going to talk about the generative AI models frameworks in general for building generative AI models. And we have 3 levels of complexity, 3 levels of what we can do, and these levels would require some expertise. Every one of these levels requires specific expertise from tech perspective. So we have 3 levels. These ones are prompt engineering on existing models, fine-tuning, which is the next level to prompt engineering, more complicated than just prompt engineering. And the third level is pre-training. So what is prompt engineering about? Prompt engineering is just using a model that exists already, and we are not going to train this model. This means that we don't have any cost in training, we don't need these capabilities to train this model and all the software behind, all the resources. We just use the model as is. But then we customize the model. So in sense of customizing the prompt, we are not going to customize the model's weights, which is different from the other two possibilities, fine-tuning and pre-training. We are not going to customize its weights and change the model, but we are going to customize the prompts, which means the way we are asking a question to the model. And this is very important. It does not require any expertise, which means that a business person can actually do prompt engineering and use generative AI models to generate the content he wants. We don't need any technical expertise in that, specifically with the advance of some tools that are making the work all high level. We can also see it from ChatGPT. For those of you who are curious, who have talked to ChatGPT, in the way you are interacting with ChatGPT and the way you are asking the question, you are likely to have different responses to that. And this is where the prompt customization comes in place. The way we ask the question matters. And this is the first part. But this way of asking a question does not require a real science background. It requires some science expertise, some science understanding of how the model was trained in order to ask the question, but it does not require any coding. This is the first level. This is for people who can achieve their tasks through just the prompting. Because in general, for example, when we are talking about a classification, a sentiment analysis, an aspect-based sentiment analysis, when we are talking about these specific tasks, entity extraction, so on, we do not really require to go deeper. Probably just a prompting, either to a zero-shot prompting or few-shot prompting, which we are going to see later on, could be sufficient to get the results we are looking for. So no need to do more. But sometimes, yes, we may need to get more, because probably the response we are getting from the model is not really accurate in regards to our expectations, and we want to make the model aware of what is it that we really want to achieve. And for that, we will need to train the model. The train of the model, and depending on the model we choose, which means the bigger the number of parameters of bigger are the number of parameters of our model, more complex is our computation, more resources are required. If we take a smaller model, then this is simpler, and then we can train it in a better way. And the same applies to the duration of training, which can range from minutes to hours, depending on what we want to do. And here we are actually tuning the model, customizing the model, and changing it to adapt to our specific training data. It requires some expertise in order to label our data. It also can be done in a very high level through some tools that can do the whole fine-tuning alone without the requirement for us to do more. Then, if fine-tuning was not enough to develop what we wanted to develop, the final stage is pre-training. And this would require days to months to weeks of work. And this means that we are creating our own generative AI models. So we are working on full from the neural networks architecture side to the vocabulary side to the context length and so on. So we are doing the whole work. And this would require a very high expertise in the domain. So in terms of how accuracies would react to what we are doing, so the customization level of our foundation model would define as well the accuracy. In general, when we are on prompt engineering, we are in the bottom of the curve. So we have the least accuracy and domain adaptation. If you go towards fine-tuning, then we are going to get more specification, which is again in accuracy in general. And the pre-training is the best option to really get something very adapted to what you do. But then it depends on the complexity, right, and cost. So the complexity and cost for prompt engineering is not comparable to the one for pre-training, because we need zero time of training for prompt engineering, and we need probably months of training for pre-training, which means that as we increase the complexity and the cost, this could probably increase the accuracy. But sometimes the accuracy we are getting out of generative AI models just through prompt engineering or fine-tuning or even partial fine-tuning can help achieve the accuracies we are seeking. Let me give you an example that I did personally with the Stable Diffusion model that I asked actually to generate for me a finch. And when I asked the model to generate for me a finch, then this is the picture that we see. This is a finch, but for me, it's an ugly finch, right? It's not Probably it's not what I really want the model to generate for me. Then I ask the model, instead of only asking to generate a finch, to generate a tiny finch on a branch with spring flowers, aesthetically inspired by Evelyn de Morgan, art by Bill Skinkwicks and Dr. Seuss, ray tracing, volumetric lighting, octane render. And so I gave more details to my model, and you see that the generation is getting better, or at least closer to what I was expecting. This is just one-shot prompting, which means I'm just asking the model to generate one thing, but this is just to portray that the way we ask the question matters to what we get as an output. And this is where we are talking about prompt engineering and prompt strategies and all of that that can help actually know how to ask the question to the model to make it generate what we really want the model to generate. And this is important. There are some discussions now about how we can actually automate all of this generation through latent representation of vectors and just trying different vectors and getting the one that can best meet our expectations. But it's really, if we don't want to go this way, it's very interesting as well to know that the way we prompt the model is important. And probably this would require some knowledge from art, from literature, along with tech knowledge in order to be able to prompt the model the right way just through one-shot prompting. The second way of prompting that is very famous is the few-shot prompting. So in the few-shot prompting, we are showing the model what we expect, and then we ask the model to generate what we want, which means that instead of only giving a prompt, which is a request to the model, I would give the model different examples of what I'm expecting the model to achieve. Like here, I'm making this for aspect-based sentiment analysis, and I'm doing it through few-shot prompting. And you can see that my prompt or my input to the model starts with review. And for example, here we have, I like the film, the actor James was not performing as usual. What are the entities and their associated sentiments, which is my question to the model. And then I give the model the answer. So the film was positive, actor James was negative. And I give the model a new review. I love the food in the restaurant, but the place was not clean. And then I ask the same questions. What are the entities and their associated sentiments? And then I give the model the answer. Food was positive, place was negative. And I give the model another example. Review, I enjoyed the hotel room, but the guy was unpleasant. And then I ask the same question. What are the entities and their associated sentiments? And then my answer is hotel room is positive, reception guy is negative. And then I do the same, but it is tricky at the end because I only put the review. I like the boat trip, but the weather was not good. What are the entities and their associated sentiments? And that's all. I don't give the answer. And I let the model generate for me the answer. So the model understood what I was willing to generate. And then the model would tell me, okay, boat trip is positive and weather is negative, which is what I'm expecting the model to do. So this is called few-shot prompting. Few-shot prompting is giving the model some examples with the according responses that we expect, and then only asking the question of our test data set data without an answer, and we ask the model to generate to generate what comes next. And this is very efficient when we want to customize a bit the prompts without really getting into the fine-tuning part. Great. So now let's be a bit more practical, and let's talk about practical tools that exist for generative AI models. And this would range from tools that are specific to AWS and tools that are not really specific to AWS, but that would probably require from you some capabilities, either in the hardware capabilities that you have in order to be able to do everything you want to do. Perfect. So the first tool, we are going to talk about these tools from the higher level to the lower level, which means tools that do not require any technical expertise to tools that start requiring some technical and scientific expertise. So we are going to go from there in a gradual way. Things that do not require from us anything from tech, which means the business person can actually do, can actually use, can actually apply. And then tools that cannot be done with the business, that only engineers or scientists probably could do with some knowledge, at least in coding and in development. So here, I'm sorry for the slides. I think that the live changes a bit my framework, but this is fine. The first tool I wanted to talk about is Amazon Bedrock. And Amazon Bedrock is the most automated way in Amazon to build and scale generative AI applications with foundations models. This is a fully automated way to do it that does not require any kind of technical expertise to do so, which means any one of us in the audience, whether we have this coding expertise or not, can be able to build things on Amazon Bedrock. How does it work? So first of all, Amazon Bedrock would give you a list of foundation models from leading AI startups and also from Amazon. Here we are talking about models from startups in generative AI, from Hugging Face, from Facebook like Llama, for example, from OpenAI like GPT, models like let's say Flantify from Google, and all of these models that exist already are foundation models adapted to specific tasks. It would also give you a description of what every model was trained on in order to help you on your choice, because probably you do not really know. And this information is available over the internet as well in order to understand how the model was trained, where it is based, where it is best adapted to, and so on. So the point is, Bedrock would give you a list to choose your model. And of course, you would just go into, you have a platform. I have a picture here. She's a bit small, but this can help us visualize that you have these different models with a description on the bottom that shows you what these models are about. You should just click on the model that you judge would be the most interesting for you and for your application case. For example, you want to do a summarization task. Then you are going to have a list of all models that are doing summarization. And you only click on one of these that seems to be the most adapted one to you according to literature, because there are some Stanford and some science and research papers that can help you make a choice. And once you have made your choice that I want to do summarization and I'm likely to go with Flantify, we are just going to click on this model. And then you will have a window opening that would help you privately customize your foundation models with your specific data. You will only do that through putting your data somewhere, which means that you are going to put your data in a certain format somewhere on cloud. In Amazon environment, it's called S3 buckets, which means just like Google Drive, for example. We are going to put your data there and give the link of this data to your UI. And the UI will understand that you want to customize this model that you have chosen in step 1 with the data that you have put in Drive 1. And so it is going to make the link and directly customize the model for you without the need for doing any work or any code on that. You can go even a level further, because if you like the model and you like the results, then you can just integrate and deploy this into applications using AWS, which means that AWS can generate for you a website or an application that can embed all you have done and all your customized model. And you can directly start interacting with your model. So this means that there is zero technicity in there, which means that you are not required to do any coding. You're just required to go and look for the best model for your application case, click on it, put your data somewhere in a drive, and then make the link between both and customize your model, and even go further into deploying it in production. So its benefits are actually the acceleration of development of generative AI applications, because we are using this through an API. We are not using code. We are not using really a notebook. It would help you as well choose from foundation models from a lot of leading startups in the domain, including AI21, Anthropic, Stability AI, and Amazon, in order to find your best model. Then, without sharing your data externally, the model would be customized on local basis in order to adapt and to fine-tune your model to your data without you doing the code, because it can be done automatically. It can protect your data using AWS security capabilities and help you go further into delivering your model, into building an application out of all of that. The second possibility is the so-called Amazon Jumpstart. So Amazon Jumpstart is a service in Amazon that can help you provide pre-trained open source models for direct deployments or notebooks in experimentations. So it's actually the same logic as the first one, but here we are going into the deeper level in terms of technicity requirements, and we are using a model that can help you have access to notebooks and have code and work on it directly from your end. So this is a platform that can help you have access to a range of pre-trained open source models that you can use for your development, for your testing, and even for your deployment. How it works the same. So in Amazon, through the SageMaker product, you can have access to Jumpstart, and that you can see here, it is a bunch of pre-trained models, notebooks, and pre-built solutions that you can use directly through a choice, through an API. Once you have clicked on that, then you have a list. This is an example of a list. So you have Hugging Face, you have AI21, you have a lot of Stable Diffusion, you have a lot of leading startups in generative AI field that can help you choose one model, and you have a discussion of every one of these models in order to make sure that what you are clicking on, what you are choosing, can help you actually meet your business requirements and solve your task in an efficient way. Once you have clicked on the model that you are interested in, and before going to that, the foundation models available, SageMaker, Jumpstart, for self-managed access are very wide. It is we have stability AI models for computer vision to generate photos, to generate images, videos, to improve quality of images, and it can be fine-tuned actually. We have Alexa models, which is an Amazon model. We have the 20 billion parameters Alexa available through Jumpstart that can help on things like machine translation, question answering, summarization, annotation, data generation, and so on. We also have models from Hugging Face, which is probably the biggest open source provider, like models like Flantify from Google, GPT from OpenAI, or even Llama from Facebook, which can help on different tasks like machine translation, question answering, summarization, annotation data, and so on. And we have some, these are publicly available models, which is the first category. We also have some proprietary models that are not publicly available, that are not open source, which we can also use. And an example of that is Cohere, which helps for information extraction, question answering. Lighton, which can help for text generation, keyword extraction, and so on. AI21 Labs, which can help with long form generation and summarization, with chatbots generation, and so on. So we have both publicly available and proprietary models to choose from in Jumpstart once you have access to these tools. So there is a strong collaboration distance between AWS and Hugging Face. So Hugging Face is probably the most popular open source company that could provide with state-of-the-art NLP technologies. And it has a strong collaboration with AWS because AWS offers the tools that we need in order to run these open source models. This includes offering high performance resources, cloud resources, ways to deploy services, and so on. So even if we have a very nice model, we need capabilities and software capabilities and resources to be able to run it. And this is where AWS comes in, because AWS can then help have all of these resources in a performant way in order to be able to use your model. So on the development, from Jumpstart's perspective, as I mentioned to you, this is the second level of depth in terms of technicity, and then you have the possibility to do it in a Jupyter notebook, like what is here. So here, this is an example of a Jupyter notebook of my own, where I actually launched on Jumpstart text generation using Stability AI, and you can see that I have in the same notebook some code you cannot read, but this is just to visualize. So it gives you the code to install and to import all the required resources, and either it is, for example, libraries or dependencies in Python, in order to be able to run your model. And then you can directly start generation. This is a small picture of what I was generating using the same model. So basically, you have a pre-built notebook that can already give you a huge starting point with everything that you need in order to start experimenting and diving deep. You can also do it through direct deployment, and this is why I said that Jumpstart is standing between the first and the last level in terms of technicity, because in Jumpstart, you can directly make a deployment of your model and then just directly start prompting through a normal UI for Stable Diffusion, which was the same model, without the requirement to go into a notebook. And so we have both possibilities. Now we have the third level of depth in technicity, which is probably also the thirdly most complicated level of analysis, which means that we are only using Jupyter notebooks in order to retrieve the weights of a pre-trained model, for example, from Hugging Face, and then work on prompting it and fine-tuning it. And in order to do so, for example, we would take a model from Hugging Face like Flantify, and then we would import all the tokenizers, and from Transformers library in Hugging Face, we are going to tokenize our data set with our model checkpoints, and we are going to create or to retrieve this model from the pre-trained model, so we can build this from scratch. And then we can start making some prompts. Probably the limit to that is that if you don't have cloud resources, it could be limiting, because depending on the type of the model we are choosing, the number of weights we are getting, the accuracy of the model would probably require more resources, which would be probably the blocking point from personal development perspective. But this is the way to do it. I mean, if we have the resources, we do it that way. We just go to Hugging Face, we take a model that is open source, and then we can import it locally into our notebook, and then be able to use the Hugging Face tokenizers and decoders in order to come to a few shot. This is an example of few shots I did through this. And then I can just retrieve so I decode the generated text from my model after I encoded my input, and then we can get an answer from that using just Jupyter Notebook. We can do in here in Jupyter Notebook more than we can do with the previous two possibilities, which means that we can do prompting, but also fine-tuning. So on the right, we have a case where I'm training a model using or fine-tuning a model on Jupyter Notebook using an open source model. And so we can actually fine-tune it to our specific model directly into our notebook. We can also do more efficient than fine-tuning if you don't have enough resources, like the so-called parameter efficient fine-tuning, which is the partial efficient fine-tuning, which is fine-tuning only parts of the model. Great, so now I will finish with some tips and tricks for customized generative AI models, which would be practically interesting for developers and scientists around us today on how they can build their generative model. The first tip is the retrieval augmented generation. So we saw that prompting, the way we prompt the model, is interesting in retrieving the information. In the retrieval augmented generation, we don't just directly give a prompt to get a generation. We also enhance this prompt with some context. For example, I want to ask the model about the time of maturity of an apple tree, for example. And instead of just asking the model what is the time required for an apple tree to be mature, I would add the context with that. So I'd go into Wikipedia, pick some text on apple trees, and then give this as a context to the model before asking the question. And this would be very interesting, actually, in order to get an information that is more interesting in regards to a certain knowledge source. So for retrieval augmented generation, so we have a prompt plus query, but then the query would go and search some relevant information in a source of knowledge. In my case, it was Wikipedia, for example, source of knowledge. And after that, it would give us the relevant information, or the so-called enhanced context to the model, in order to give this as a first context before asking the question. And so we will have a prompt plus the query plus the context in order to ask the question. And only after that, we are going to retrieve the answer, or to trigger the answer from the large language model in order to generate for us a text response. This is a very nice idea, I think, for people who are seeking to also enhance this with some context, because the fact that generative AI models were trained on huge amount of data means also that sometimes we are not really getting the information that we need. But if then we have a source of knowledge we want to retrieve, we can do this in order to have an augmented generation that would be certainly more accurate. Another tip, partial efficient fine-tuning. Instead of fine-tuning the whole model, we can only fine-tune part of the weights of the model. For example, here we have 20 billion parameters of a model, which is huge. If we want to fine-tune this model, then we need huge resources. But we can do that through just training a certain set of weights, not training the whole weights, not training the whole 20 billion parameters, but only, for example, 20 parameters out of these 20 billion parameters. And doing so, we can actually achieve better accuracies than only prompting, but then also not require huge amount of resources, which would be practically interesting for developers who are faced with these problems in resources. Last tip is reinforcement learning using human feedback. And in this case, for example, if we want our model to be less aggressive towards our customers, or to be nicer, to be more polite, then we can, for example, use a reinforcement learning model that will benefit from human feedback, for example, to enhance these capabilities and to let the model be more polite. You can also use this, for example, with some tools that can help us get an assessment of the politeness of a model, which are tools that are open source. There's one with Facebook that can actually tell you, when you have generated a sentence, whether this sentence is is polite or not. And then on this basis, we can have a reinforcement learning agent that learns from this generation to generate more polite answers, for example. And this is another interesting tip in order to be able to customize your generative models. So my presentation comes to an end. It was very nice being with you today. Now we are going to move to questions and discussions. I'd be happy to discuss with any one of you. For those who are interested in getting more resources, more data on that, I'd be happy to share my email, and you can text me. I can share with you a bunch of tutorials on YouTube and data resources documentation to help you get deeper into the technical sides of that.
Thank you, Sosan, for this presentation. I would like to ask you first a question. Do you want to do questions with English or Arabic or?
I don't really mind. So any language would be good.
Okay, so let's do this. I suggest we answer every question with the language you was asked.
I
Okay.
agree.
So I think I'll take out this slide. Okay. Okay, here's a question. Thank you for this opportunity. About a source of knowledge, is it letting the AI search in some certain sources like Wikipedia, or it searches like the whole net?
No, it's really customized source knowledge. You can use, for example, as some internal wikis in your company, internal documentation. Whatever you find as very useful in order to get more current resources. For example, in my case, I would not use neither Wikipedia nor web nor anything. I would use the documentation that I have in my internal data sources that can help people internally understand what is going on, and I use this to enhance it. So it's not neither Wikipedia nor web nor whatever. It's what you judge would be useful in this enhancing purpose.
Thank you for this answer. Before going on with the questions, I would just like to say that I have posted a link to a form. If anybody has a suggestion of what you want us to discuss in any next webinar, any subject that you would like, just let us know. So if there are any other questions in any language you want, Français, Derija, English. Okay. How to become a prompt engineer?
Yeah, this is a good question. Prompt engineer is about learning how to retrieve or how to get the best out of a model from doing so. So this requires some information on how models were built. So the more you know how a model was built, how it was trained, the better it would be on retrieving this model. If you know, for example, that the model was trained to generate the next word, this is interesting information from this perspective, because you can try to mimic this in order to do that, in order to prompt it the right way and let it follow his training. You can also do it from knowing the tasks on which the model was trained. For example, doing this on summarization and so on. So it requires some technical perspective from this perspective. It also requires some tests. It requires some probably literature kind of sense in order to know how to ask the question, how to try different questions. There are a lot of documentations online on how we can retrieve a model, for example, for image generation, that would give you the way we can formulate the context, the way we could formulate the question, the details that we need to integrate, for example, on volumetric, on background, on surroundings, and so on, so that you can try to create your own. And there is an even interesting part, which is the automation of prompt tuning, because this is a new direction. We are trying to automate the prompts, which means instead of someone trying different prompts to get the best of the model, we have the model train itself to get the best. And in order to do that, we are going to instead, because when you are talking about a sentence would have a latent representation. A sentence would be turned into a vector in order for the model to understand it. So this is referred to as latent representations. And this direction in automating the prompt engineering means that we are playing on these latent representations and optimization for the required output. So this is something also interesting to be aware of in order to have the full picture, I think.
All right, thank you for your answer to this question. We move on to the next question, which is, Don't you think generative AI limits human creativity? Like it seems he can do almost everything.
This is a philosophical question. I don't really have a yes and no question to that. I just think that it would limit some things that that needed a huge amount of time to do, which now can be done more easily. But I think that it can also um, trigger our creativity because we have all of these tools. But the question is how to create value out of all of these tools. We have ChatGPT, we can interact with it. It is accurate enough for some tasks, but how are we going to create business value out of that? How are you going to apply this to specific cases that would generate profit or that would generate a certain value? Either it is a value that is related to profits or a non-profit value at least. How can we create something interesting out of all we have? And this is the most I think critical case because the trickier part is not in having the model, having the resources. The critical part is knowing how to apply these resources to generate something interesting. And this is where creativity can be done because we have tools, but then they cannot they do not generate value. And I think we need a lot of understanding of what these tools are capable of doing, what resources we do have, how we can retrieve these, and then understand also what is happening in operational perspectives, whether we are in a business where we understand the internal strategic questions in this business, or even when we are talking about general topics. So we need to understand how to make this link. And this, I think, only humans can do, at least now, but we will see.
All right. Okay. Next up, we have are there any limitations to generative AI models that researchers are actively working to overcome?
Absolutely. I think out of the possible, there are many limits. The first limit is responsibility, which means that in the field of responsible AI, these are black box models. These are highly black box models. How can we make these models accountable? How can we trust these models? How can we explain what they are saying? How can we understand how they reflected? This could be a very sensitive ethical question, specifically when it comes to applying these models to some sensitive topics, like, for example, in healthcare, or applying it in, for example, something related to social cases where we can have a huge problem in terms of responsibility of these models. So this is an open question that researchers are actively working on. The second question is on robustness. So these models, we don't really expect what the output would be directly, and we don't know. For example, if you ask the same model the same question but in different ways, it is likely that you get different answers. So how are we going to build this robustness? How are we going to make sure that these models generate something that is at least significant and correct? Given that we don't know the black box aspect of it, which is, I mean, when I'm talking about the black box aspect of it, there are problems that come from deep learning in general and from machine learning in general. It's not really related to generative AI models as such, but given that generative AI models are among these black box category of models, so we have all of these problems. But I think that the robustness question is something very related to this, because as we mentioned, prompt engineering, how we retrieve the data from model, how we customize it. The question we have is how to build something that we can trust out of this, that would not change if we change the way we are asking the question. And these are these are limits that that we are working on right now.
Okay. So a more practical question, which is, I want to build a simple chatbot which can read my PDF and can answer questions for free. Is this possible?
So building a chatbot can read and answer questions is possible, of course. Is it for free? I think that the limitation you will have is on the resources side, because in order to, for example, I mean, you have a lot of models. You have some models that are light, but in general, the more accurate models require are huge models. So they are huge models, and if you want to use them, if you want to embed them into your notebook and run them and develop on top of them, you need some resources. So this is where the free is not possible, while the first part of the question is possible. So there is work around this as well in terms of trying to get smaller models with better efficiency. But in general, there is this, I mean, if I use, for example, Flanty5 with the base version, it is much less accurate than Flanty5 with XL version. But then Flanty5 with XL version would require huge resources that are not required for the first one. And this is where it's very complicated to do it for free.
Okay, so now we have a question in Arabic, which is okay. I think the Arabic is not showing correctly, so I'm going to read it from here. هل صحيح أن 80% من الموظفين الآن في المغرب لا يعرفون أي شيء على AI وكل مقاولة ديجيتال؟
كنظن بلي هاد السؤال خاصنا نديرو دي ستاتيستيك أنا ما عنديش
And actually there's a sequel. هل صحيح ولماذا وكيف نعمل على تحضي هذا؟ What do you think? I think it's a general question about AI in Morocco, which could be interesting.
Yeah, I think that
Maybe in Arabic.
exactement. دونك البورسونتاج ديال 80% ديال الموظفين انا ما نقدرش نجاوب على هذا السؤال خاصنا دي ستاتيستيك دي ريفيو دي فوالا نديرو comment on appelle ça genre des questionnaires avec des gens pour savoir où ils en sont. بالنسبه للقضيه ديال اننا خصنا نزيدوا النوليدج في المغرب ونكثروا المعرفه على الاي اي. I think it's important. كنظن بلي هذا سوجي مهم. هادشي علاش انا كنفرح فاش كنلقى مبادرات بحال ديال ماتي ماروك بحال ديال مروكن اي اي سيتيرا اللي كي فيز او موان تبدا لا ديسكوسيون في المغرب. نبداو كنفكروا في هاد لي سوجي باسكو لي زابليكاسيون ديالهم راه مهمين بزاف. Et c'est très important اننا نبداو une adoption ولا au moins واحد la compréhension على اتساع وبكري باش اننا نقدروا نافونسيو et نقدروا catch up avec les application cases اللي ما مطبقينش دابا j'imagine.
شكرا على الجواب. دونك باقي شي دو كيسيون. Okay. I don't know if you answered this question before, but it says it possible to use generative AI in some of the classic computer vision tasks like image segmentation classification.
I think because I mean this capability of generation includes also capability of understanding what you are generating, which means that this tricky part can be used in order to recast some of the classical computer vision tasks into that. We can I mean I think that if you look at resources like in the internet you do have the application cases of what computer vision models can do, but since they're able to generate, they're able to understand, so we can use this capability for that.
Great. I think one or two questions and we'll be done, and it's 1 hour, so that's great. Good timing. So thanks for this great presentation. I'd like to ask you, how can developers learn to get started in AWS, microservices in general?
I think the best way to do it is through YouTube tutorials. So if you go to YouTube and you look for AWS tutorials, there is plenty of resources that would help you. For example, all I discussed in Bedrock, in AWS Jumpstart and all of that, you can find on YouTube some live demos that can help you actually visualize and see how these are developed. I think it is the best way to get started because these are free resources, open source, but that can help you really understand how from technical perspective it works, and this can help developers learn how they can get started with these services. On the application side, this requires being able to have these services, so either as a personal use or professional use, to be able to apply this. But at least from a learning perspective, I think tutorials is the best way. Then you can have some opportunities, specifically in Europe and in the US, which are a bunch of events around summits, which are called in general summits or conferences and so on, where AWS services are present to present to you their services, their methods. They can be scientific, they can be tech, and from there you can learn a lot on what exists already. And I advise every one of you who can have access to this to get registered. Some of these are for free, some of these are not for free, but there is one around generative AI where I will be present and I will be a speaker in London on September 15th, which will be very directed toward generative AI. So for all of you who can do it, please come, and you can learn a lot from these events as well.
All right, let me see if we still have questions. Okay, so What can we say about the explainability of generative AI models, if that makes sense?
I think this is the critical kind of one of the critical points of generative AI models, because when we are talking about deep learning in general, transformers in particular, and generative AI models in specificity, so we know that they are not that explainable. There is work to try to explain them, but this is an open topic, and that is sometimes very important to the business, because sometimes the business just wants a simple model that they can at least interpret and explain, instead of a very sophisticated model that they don't know, that they don't understand, that they cannot explain. So it is not accountable for the decisions it is taking. This is why I think that this is a sensitive topic. There are a lot of research work on that direction, so you can check the papers on that side. Yeah, and this is for me one of the limits that scientists are working on in order to come with an explainable vision. We have some methods to do so. We have some ways to try to explain the behavior, but yeah, I advise you look at the literature on what exists for it.
All right, I think we can take one last question and we're done. Okay, one last question. Est-ce que certains modèles d'IA générative ont atteint un niveau de maturité qui leur permet d'être industrialisés et intégrés dans les systèmes éducatifs?
Je pense que oui. Pour l'industrialisation et pour le système éducatif, ce sont deux questions totalement différentes. Donc pour l'industrialisation, oui, parce que si on les compare avec les modèles qu'on peut développer avec du NLP normal, on va voir qu'on a un gain en efficacité, en productivity, parce qu'on peut avoir des modèles très rapidement, qui permettent quand même d'être bien benchmarkables avec des modèles qui ont peut-être requis des mois de travail. Donc je pense qu'ils ont atteint le niveau de maturité qui leur permet d'être industrialisés, avec bien sûr un effort en plus en amont pour pouvoir, par exemple, les adapter, les customiser aux besoins industriels spécifiques à travers les outils techniques qui existent pour ça. En revanche, pour l'intégration au système éducatif, donc je vois qu'il y a eu des initiatives, par exemple à Télécom Paris Tech, où ils auront un robot qui va faire office de prof dans une conférence, un truc comme ça, mais je m'en doute beaucoup. En fait, j'ai des questions, parce que pour des modèles qui ne sont pas accountable, qui ne sont pas explainable, etc., je ne saurais pas répondre à cette question. Et pour moi, il y a encore du travail à faire avant de pouvoir les intégrer dans des systèmes éducatifs qui, eux, vont requérir un niveau de rigueur et de précision plus précis qu'en industrie.
Super. Je pense que c'est bon. Donc, shukran Sousan à la conférence, le webinaire. Saraha, j'ai remarqué que ça a eu pas mal de succès, il y a pas mal d'activités, il y a pas mal de gens qui sont venus, donc merci beaucoup. Je pense que vous avez ça n'a rien donc, je le rappelle encore une fois, il y a quand même comme ces suggestions de choses les بريسيون نهضروا عليهم في live ديال l'association. عمروا الفورمulaire les soft في les commentaires Facebook ou YouTube. Et à très bientôt pour un prochain webinaire.
Merci beaucoup, Omar. Merci pour cet effort et pour toutes les conférences que vous organisez. Ça me fait vraiment plaisir. Je vous suis de près et les conférences, les événements. Donc franchement, bravo, parce que c'est un projet qui a commencé par des étudiants, des collègues, et qui franchement a un impact énorme. Donc je vous félicite énormément et je vous remercie aussi pour toutes ces initiatives, les Kadirouf El Maghreb, et qui font plaisir à tout Marocain.
Merci beaucoup. À très bientôt.
Très bientôt.